So lesson 4 about the derivative as the slope of the tangent line. So ito yung mga learning outcomes natin. So at the end of the lesson, the learner shall be able to illustrate the tangent line to the graph of a function at a given point. Apply the definition of the derivative of a function at a given number and relate the derivative of a function to the slope of the tangent line. Okay? So i-discuss naman natin ito, so I will not go deeper sa mga ito. Basta ito yung mga di ba outcome based tayo. So ito yung mga dapat nyong matutunan at the end of the lesson. So first topic, the tangent line to the graph of a function at a point. So syempre, we need to have a foundation sa tangent line. So what is a tangent line? Ito na ba yung tangent line? So this is not yet the tangent line class. So this line class is what we call a second line. Okay? So first, this is a graph of this particular function. So general function, so y is equal to f of x. So this is actually a curve. So ito yung graph nito. Ngayon class, a second line is a line na tatama sa 2 points dun sa curve natin. In this case, P at saka Q. So take note, 2 points na. And those 2 points, point sila ng kasama sila dun sa points ng graph na yun. Okay, hindi pwede dito yung point. Hindi rin pwede doon. Kailangan yung 2 points is nasa graph or curve. So again, this is a second line. So how about this graph? So PQ yung kanina, di ba? Let's say, nag-draw pa tayo ng several second lines. So we have Q1, point Q1, point Q2. So ito yung mga lines na yan. Okay? So yung mga points, if you notice, is papunta doon. So we can actually make several more na second lines, di ba? Just dito. And then, if you notice, papunta yung points dito sa P. The points are approaching P. Ngayon, kung papunta sa point na yon, there will come a time na there will be a limiting position of that line, of that second line. So ito yon. Okay? So it's like yung from the word limit. So ito na yung max na pwedeng second line. In this case, class. In this graph. Okay? So that limiting position, class, that line wherein isang point na lang siya. So it's like nag-combine yung P at saka Q sa isang point, di ba? So that is the limiting position. So this line, ito na yung tangent line. Okay? So tatama lang siya sa isang point sa curve. Hindi katulad ng second, dalawa. Ibig sabihin, class, pwede tayong magkaroon ng maraming second lines, pero unique lang yung tangent line natin. Isa lang siya. So yun yung kagandahan ng isang tangent line. So it is unique per every graph. So let's define formally. So by the way, yung C is yung graph. Let's say, yung pangalan ng graph natin is C. So let C be the graph of a continuous function. Pag-aralan natin yung continuous, di ba? Y is equal to f of x and let P be a point on C. P be a point on C. A second line to y is equal to f of x through P is any line connecting P and another point Q on C. So, ibig sabihin, from P, second is any line connecting from point P to Q, another point dun sa curve. Okay? What about the tangent line? Gaya ng sabi ko, it is the limiting position. So, tangent line to y is equal to f of x at P is the limiting position of all second lines. PQ, ito yung representation ng second line natin, di ba? Yung PQ, as Q approaches P. Try to remember yung limit, di ba? Merong limit of the function as x approaches a constant. So dito, yung limit ng mga second lines as Q approaches P. So yun yung tangent line. Di ba ina-approach ng Q yung P class? So therefore, isa lang yung magiging tangent line natin. Ito siya. That is why the tangent line dito and then a second line. Ibig sabihin kung a second line, possible na marami. Kapag the, so it is unique. Iisa lang. Diba? Okay. So yun na yung background for tangent line. So, pero yung importante sa calculus class is the tangent line. So we are after here. Bakit din-discuss yung second line? So syempre para ma-discuss natin yung mas maintindihan nyo yung tangent line. Pero yung tangent line talaga yung basis ng kumbaga yung dinidiscuss natin. Okay. So the equation of the tangent line class. So na-discuss na natin yung tangent line, di ba? So paano naman makukuha yung equation nun? So for every line, we have an equation. Before we discuss about done, so let's recall yung slope of a line. So slope of a line is computed with this formula. So we have 2 points, x sub 0, y sub 0, and x at saka y. Okay? So itong points na to, point sila ng isang line. Okay? So hindi sila point na kung saan lang. So kabilang sila sa isang line. So yung slope nun is computed by this one, y minus y sub 0 over x minus x sub 0. Okay? Example. So given this 3 points, so what are the slopes of lines AB, AC, and BC? So discuss na lang natin yung AB. So if you will plot this, so 1, negative 3, 3, negative 2. So from here, so ito yung x sub 0, y sub 0 since siya yung nauna, then x and y. X and y. So y, so negative 2 minus 3. 3 minus 1. Okay, so that is negative 2 plus 3. That is 1. And then 3 minus 1, that is 2. So yung slope nito is 1/2. Okay? And then we have yung point slope form. The line passing through x sub 0, y sub 0 with slope m has the equation, this one. So this is the point slope form class. So meaning, isa-substitute mo yung point na given dito. Example. So yung kanina unang example, nakuha na natin yung slope, which is 1/2. And then, we will use yung first point, which is yung A. 1, -3. Okay? So we can use this one to get the equation nung line. Okay? So substitute mo lang yung 1, -3 dito. So -3 and then even yung m, which is yung 1/2. Then x sub 0, which is 1. Take note, be careful with the signs. Okay? And then, simplifying, so magiging ganito siya. Pwede mo pang i-simplify ito actually. Pwede mong gawing y is equal to mx plus b form. Okay? That is yung slope-intercept form. Okay? So, na-discuss na natin kung paano kumukuha ng isang equation of a particular line. Ngayon, paano naman kumuha ng equation ng tangent line? Okay, so we have here the figure before. Again, this is the tangent line. We have yung second line na PQ class. Okay, so paano natin makukuha yung slope nun? So makukuha natin sa class by using limits. If you notice, di ba yung particular line, this one, we can get yung slope nito class by using yung kaninang formula. Ito, di ba? Ngayon, we can get actually yung slope nitong tangent line by limiting this slope as x approaches x sub 0. Di ba kapag lumalapit ito, imagine class, lumalapit itong x na to, which is value ng q, doon. Ito yung lumalapit to, doon makukuha yung point nung tangent line, di ba? Ito yun, yung lumalapit siya. So, x approaches x sub 0. So, ibig sabihin, to get the slope class, we can use this formula. So, limit ng slope formula as x approaches x sub 0. Okay? Ngayon, yung y, pwede mong palitan ng f of x. And then yung y sub 0, yung f of x sub 0. Okay? Kasi yun yung function, di ba? So therefore, to get the equation of the tangent line class is first get the slope by using this formula. Yung limit ng y minus y sub 0 over x minus x sub 0 over, as x approaches x sub 0. Kasi nga, para makuha yung slope niya class, we need to limit itong slope ng mga to as x approaches x sub 0. So, if nag-approach yon, imagine, so pupunta siya doon para maging tangent line siya. Okay? Kaya, na-derive itong formula na ito. We made use yung limit kasi nga limiting position yung tangent line. And then applying yung point slope form class, so nakuha na yung slope by using this formula. And then you have the single point. Diba? So you can substitute again yung point x sub 0, y sub 0, and then yung m. Okay, example. So, pwede naman na x sub 1. Yes, pwede. Pwede naman, this is yung ginamit lang na variable. Make sure na yung final point minus original point. Or actually dito class, pwedeng yung mauna is yung ito. Pwede naman negative 3 minus minus 2, 1 minus 3. Basta yung pattern is ito ima-minus doon. Or ito ima-minus doon. Hindi pwedeng opposite. I mean, iba yung nasa taas, iba yung nasa baba. Okay? So example number 3. So find the equation of the tangent line. Ito yung first example actually natin regarding this. Find the equation of the tangent line to y is equal to x squared at x is equal to 2 ito klasa. Mali lang na kumbaga typo lang. At x is equal to 2. Okay? So in this case, 2. So using yung formula class kanina, so pinapanap yung equation ng tangent line, di ba? So we already have the graph. Ito yung graph nung y is equal to x squared class. Okay? And then this is the tangent line. So how do we get yung equation nito? First, we get the slope. We can get the slope by using the formula. Ito. Okay, ano yung y sub 0 dito? So meron tayong isang point class. Ito na yung x sub 0 natin. Okay? Which is yung 2. Ngayon, to get the y sub 0, we can substitute yung 2 sa equation natin. Which is 2 squared. So y is equal to 4. So that is why 4 doon. Okay? And then, yung x sub 0 natin is 2. Yung y is equal to x squared. And then as it is si x. Ngayon, paano naging 4 class? Kung i-direct sub mo siya class, 2 minus 2 is 0. Which is, iniiwasan natin yun, di ba? Kasi mag-undefined siya. Ngayon, we need to have another way para makuha yung limit. So we can factor this out, x minus 2 multiplied by x plus 2. Okay? So kung x minus 2, x plus 2 ito, so makakancel yung x minus 2 sa taas and then x minus 2 sa baba. May iwan is x plus 2. Kung x plus 2 na ito, sub na yung 2. So 2 plus 2 is 4. Okay? So nakuha yung m is equal to 4. Ngayon, we now get meron na tayong slope. So we can now sub this to using the point slope form. Okay? So we have yung x sub 0, y sub 0, 2, 4, and then yung slope. Arranging this, we get this one. So therefore, this is the equation of this tangent line. Okay? So another. Equation, find the slope-intercept form of the tangent line to f of x equal to square root of x at x equal to 4. So another, we need to get the equation of this tangent line. So this time, square root of x na siya. I mean, y is equal to f of x. So, f of x equal to square root of x. So, ito yon. Okay. So, again, we will use the formula. So, yung first step, class, is you need to get the slope. So, yung mga points is, yung x is 4, yung y is square root of 4, 2. So, dito naman, 4, 2 yung points na gagamitin natin. So, this is actually yung point of tangency. Yung point kung saan tatama sa curve. Okay. So, paano naman kinuha yung slope dito? So, f of x, yung mismong function natin, which is square root of x. Square root of x. And then, minus nung f of x sub 0. Kapag sinabi yung x sub 0, that is 4. Diba? So, square root of 4 is 2. Kaya 2 dito, class. Over x minus 4, yung original, yung x natin. Then multiply. Bakit minultiply sa, this is multiplying conjugate, class. Kasi we need to rationalize the numerator. And kung i-direct sub yung 4 dito, class, mag-undefine naman siya. So we will find another way. So rationalize, conjugate, it means the same terms lang pero different sign. In this case, susundan yung nasa numerator. Kakapi lang yun sa denominator. Okay? And then multiply. Kapag minultiply yan, class, magiging x minus 4. And then this one. And then cancel, magiging 1 over square root of x plus 2. And then pwede mo na siyang isub. Hindi na siya mag-undefined. So yung answer dito is 1 over 4. Yun yung slope. And then isub dun sa point slope form natin. 2, 4, 1 over 4 yung mga given. So you will have this equation. So ibig sabihin, ito na yung equation ng tangent line natin. Okay? Okay, definition of the derivative tayo. So, na-discuss na natin ito yung formula to get the slope, class, di ba? Pero actually, this is actually more than just the slope of the tangent line. So it can also mean relative change of the function on the time or space interval between x sub 0 or x. Di ba makikita nyo dito, fraction siya. So di ba pag fraction, rate of change yon kapag fraction. Imagine yung meters per second, di ba? So fraction sila. So this is actually like a rate of change. Specifically instantaneous rate of change with respect to x. Okay? So kukuha ka ng change ng y over change ni x. So rate of change. Okay, so let's define formally yung derivative, class. If discuss yung kanina, sabi natin instantaneous rate of change. This is actually also the derivative, class. This is also the formula for derivative. So nandito na tayo sa derivative. So, ito yung merong prime, f prime or apostrophe. Ito yung designation ng derivative class. Take note. So, ito yung f prime x or kapag ganito, pwede rin. Kapag merong d doon, then f of x or y, since y is equal to f of x or ganito. This denotation class are all the same. Okay, take note. The same lang, it means derivative. Okay, so let's compute some examples. So compute yung derivative or f prime of 1 for each of the following functions. Take note yung 1 doon is actually yung x sub 0. Okay, so we will get the derivative of f at a specific value of x. In this case, 1. Okay? So, bali magiging ganito siya, class. Based dun sa formula, ito. So, papalitan natin yung x sub 0, x sub 0 dun, x sub 0, x sub 0 dun ng 1. Okay? So, let's start dun sa first example. Dito. So, 3x minus 1. So, first, para hindi tayo mahirapan, class, kunin muna natin yung f of 1. Di ba kailangan yung f of 1 dito? Pag sinab, 3 times 1 is 3 minus 1, that is 2. So, 2. Yung f of x is yung mismong function lang. Ito. And then minus 2. Kasi 2 ito, di ba? Over x minus 1 as it is. Okay? And then, ano nangyari dito? Bakit nawala yung 2? So, 3x minus 1 minus 2. So, magiging minus 1 minus 2, that is negative 3 class, di ba? And then, kung 3x minus 3 yan, try to imagine, wala kasi akong, di na ako pwedeng mag-annotate yung magsulat. So, 3x minus 3. So, factor yung 3. So, magiging ganito siya. So, cancel, cancel. So, we have this limit. As you all know, limit of a constant is the constant itself. So, 3 yung sagot. How about the second? F of 1 dito is 6 class. Kasi kapag sinab yung 1 dito, so 2 times 1 square, 2 plus 4, so 6. Kaya minus 6. Then write the function, x minus 1, retain. Okay? So ano naman nangyari dito? Nag-factoring. Kasi class, bakit natin ginagawa ito? Kasi kung dinirect sub natin siya, 1 minus 1, mag-undefined siya, di ba? In-explain ko naman yan before. Di pwedeng mag-undefined kapag limit. So we need to find another way. So in this case, factoring. Okay? So 2x squared plus 4 minus 6. So magiging negative 2 ito. So 2x squared minus 2, di ba? Factor yung 2. Maiwan is yung x squared minus 1. X squared minus 1 is factorable by this one. Okay, so cancel, cancel. So we have 2 multiplied by x plus 1. And then sub si 1, hindi na siya mag-undefine, kaya 4. How about yung third example? Again, kapag sinab ito, yung 1 sa original equation natin, ito. So yung 2x over x plus 1, di ba? So 1, 2 times 1 is 2, and then 1 plus 1, so 2. 2 over 2 is 1. Kaya 1 dito. And then copy yung x minus 1. Okay, so dito mag-undefine na naman kapag direct sub. 1 minus 1, so 0. So let's find another way. So multiply sa conjugate. Kung negative yon plus. So kasi pwedeng mag-multiply ng conjugate, depende. So pwedeng i-rationalize kasi like kung radical yan, pwedeng i-conjugate yung numerator or yung denominator. Okay? So in this case, conjugate natin yung nasa baba. So x plus 1, x plus 1. Okay? So magiging ganito siya. So distribute. Kapag minultiply natin to doon, maka-cancel sa x plus 1, di ba? May 1, 2x. And then, multiply ito, magiging ganito siya. Over this one, 2x minus x is x, and then magiging minus 1 yan. Over this one. Cancel, cancel. May 1 is 1 over x plus 1. I-sub si 1, magiging 1 over 2. So this is the final answer. And then yung 4, ito yung original na function natin. So pag sinab si 1, 1 plus 8 is square root of 9. So kaya 3 minus 3. Then over x minus 1. Ito yung sinasabi ko, class, rationalize the numerator since radical sign ito. Okay, so multiply. Conjugate, so kung yung conjugate class is the same terms pero opposite signs lang, negative, positive. Okay, para ma-rearrange lang natin yung equation natin. Kasi pag dinirect sub ulit ito, mag-undefine siya. Okay, so magiging ganito, x plus 8 minus 9. Kapag minultiply ito, and then yun, multiply. Magiging x plus 8 minus 9. So magiging x minus 1. Diba? Cancel, cancel, matitira ito. I-sub si 1. 1 plus 8 is 9. Square root of 9 is 3. 3 plus 3 is 6. So this is the final answer. Okay? Equivalent definition of the derivative. Ngayon class, ito yung kanina, di ba? Ngayon, pwede natin palitan yan ng merong delta x. Take note, this is a single variable, hindi siya triangle multiplied by x. Ano yung ibig sabihin ng delta x? It's like yung change of x. Ayan. Yung delta x is yung kumbaga yung nadagdag kay x sub 0. From point P hanggang Q, yung nadagdag is yung delta x. Kumbaga yung change, yung increment ni x sub 0. So hanggang doon, x sub 0 plus delta x siya. Okay? Kaya pwede natin siyang gawing yung overall na x, it means x sub 0, x sub 0, ito, plus delta x. Okay? So kung meron na tayong ganito, isub siya dito. So x, so as it is, and then isub si x dito. So magkakaroon tayo ng ganito. Ngayon, mangyayari dito is Makakancel na lang si x sub 0 dito, di ba? May iwan si delta x. Okay? So kung maiwan si delta x, so magkakaroon na tayo ng ganito. Gawin nating x na lang itong x sub 0. Ito, so naging ganito siya. So ibig sabihin, yung alternative definition ng derivative class, which is designated by prime, is also this one. Diba? So nililimit natin yung ito as delta x approaches 0, which is equal lang din siya. So kapag nilimit natin ito class as papuntang 0, so if nagiging 0 ito class, ibig sabihin tumudusog ito doon. 'Di ba? Which is yun yung kailangan natin to get the tangent line. Okay? Ngayon, para lang hindi tayo ma-confuse, we can replace yung delta x sa age. So pareho lang siya. Delta x tsaka yung age just means yung change na nangyari kay x dito. Okay? Ayan. So for tomorrow, we will have example of this one. And then we will discuss yung about differentiation. Okay? So we have instantaneous velocity of a particle in rectilinear motion. So this is, we are talking about particle. Okay? So di ba yung a particle can also move. So yung motion niya is in rectilinear. So this in linear motion class. So first, we have the position function. It's like ito yung function that could represent yung location or yung position ng function. Nasaan ba yung position ng particle natin? So we can represent it as a function. Let's say, ganito siya, s equal to s of t. Wherein time is greater than or equal to 0 class. It means, hindi pwede yung negative time. Siyempre, di ba? It's like going back in time. So wala namang ganun. Example number 3. Suppose that a particle moves along a line with position function. So ito yung sinasabi ko, class. Function, ito yung magre-represent para makuha yung particular position ng isang particle. So you will just need to substitute yung time. For example, what is its initial position? Saan ba nakalugar yung particle natin as its initial position? Ano ba yung time kapag initial position class? 'Di ba? 0 kasi initial pa lang. Therefore, isub mo lang yung 0 dun sa function natin. So kung sinub mo yan, 0, 0, therefore 1. So S of 0 class A. It means yung unit natin is actually in meters. It means 1 meter to the right of the origin yung position ng particle natin in this example. Kumbaga, at the initial position niya is nasa 1 meter to the right. Okay? Then, tinatanong yung after 2 seconds. Kung after 2 seconds, so bali, isub mo lang ulit. So, nasa 15 meters to the right siya. Okay? Ito siya. So, at the initial, nandito siya. After 2 seconds, syempre we are talking about particle class. So, sobrang bilis niyan. 15 meters. Okay? And then, how about this one? Paano nakuha ito? At this location, after 1 second siya nandun. Ito yon. So given, in this case class, given yung position niya, kukunin natin yung time. Ito. At what time is the particle at position S is equal to 6? So ibig sabihin, given yung position niya, therefore equate natin siya sa 6. Kunin natin yung time. Okay? So factoring 2t plus 5 quantity t minus 1 is equal to 0. Makukuha nyo is 2 values of t. Negative 5 over 2 or t is equal to 1. Ngayon, i-disregard natin yung time na negative. Kasi nga kas wala naman negative time. So 1 second yung sagot dito. Okay? So yun yung position function. Ngayon, let's discuss about instantaneous velocity class. So we've discussed yung position. So for every point class, meron tayong tinatawag na instantaneous velocity. So at time is equal to 0, iba yung velocity. Pero possible naman the same if constant yung velocity. Pero let's say iba-iba yung velocity ng particle. So ibig sabihin ng instantaneous velocity class, at this instant, so instantaneous, ito yung velocity niya. At this instant, meron siyang particular velocity. At this instant, meron siyang particular velocity. So yun yung tinatawag natin instantaneous velocity. So para makuha yon, kunin mo lang yung limit. Ito yung gamit ng limit. Ililimit mo yung time as x approaches, as t approaches a particular time, in this case second. Okay? So notice the same lang siya nung kanina, di ba? Kasi this is the general formula for derivative. This is actually an application of derivative class. Di ba ito yung derivative kanina? Pinalitan lang, iba lang yung variable dito. S and t. Kasi we're talking about position and then yung time. So kung position over time, it's like distance over time. Diba? That is why meron tayong velocity. Velocity is equal to distance over time. Okay? Kaya meron din kanina yung rate of change. Change, we can do that by getting the difference, diba? Change in position over change in time. Kaya tinatawag yung derivative, application ng derivative is yung rate of change. Okay. Let's have an example involving instantaneous rate of change. So a ball is shot straight up from a building. So let's say ito yung building, nandito ka, tinapon mo yung ball. Ayan. Pataas, and then, syempre, mahulog siya. Ayan, doon. So tinapon mo. So yung height ng ball in meters from the ground at any time t in seconds is given by this position function. So ibig sabihin, class, itong height ng ball from the ground siya, ito yung function niya. So find the height of the building. Paano natin mahanap yung height ng building? Mahanap natin yung height ni building kapag initial time, di ba? Kasi itong position na ito, class, kasama na yung, from the ground siya. So kung time is equal to 0 dito, makukuha natin yung height ni building. Di ba? Kasi dito ka pa lang mag-start. Get? So therefore, S of 0 tayo. Kung S of 0, 40 siya. Yung 40 dito, it makes sense kasi sinama yung height ng building, di ba? So this is like, ito lang yung actual na position function ng ball. ito na yung height ng building, 40. Next, the time when the ball hits the ground. So, di ba tinrow yung ball? Dito siya. May hit niya yung ground niya. Ngayon, time yung kailangan natin dito. Ano yung position ng ball kapag nandito siya? Dito naman, siya 0. So, S is 0 naman dito. Baliktad. Dito, height. Dito class, yung time is 0. Dito, yung S is 0. Kasi hinanap natin yung time. Ayan. So, 0. And then, finactor. Makukuha nyo is yung dalawang values, which is 8 tsaka -1. Wherein, disregard yung negative, 8 seconds. So, after 8 seconds, nasa ground na siya, class. So, syempre, mabilis yun, 8 seconds, di ba? Pull of gravity. And then, average velocity. The average velocity of the ball, interval 1 to 2 between 1 to 2 seconds. We've discussed yung instantaneous velocity, class. Average naman, class, from the word average. So, yung mean velocity niya in a span of time. So, meron period of time. Diba, instantaneous is from an instant. Average is like yung general velocity. So, in between interval siya. So, dito, 1 to 2. From initial na after 1 second, then after 2 seconds. Okay? So, gagawin mo lang without the limits yung average velocity, class, without the limits. Kasi kapag in-apply yung limits, yun yung instantaneous. Okay, so S of 2 is 90, S of 1 is 70, then 2 minus 1. So we have 20 meters per second yung average velocity kapag 1 to 2 yung interval, yung seconds. Instantaneous velocity naman, class, ito yung sinasabi ko. Kapag time is equal to 1 second, ano yung velocity at that instant? So yung formula natin, dito nag-a-apply ng limit. Okay? But you cannot directly sub yung 1 dito. Again, ito yung, it's quite interesting din na, syempre kung sinab mo siya undefined, di mo makukuha yung limit. So you have to do some factoring. So ito yung factoring nito. Okay, assignment nyo na lang kung paano na factor yon. So, t minus 1, cancel, cancel. 25. Then kapag time is equal to 2 naman, so ganito siya. Siyempre, papalitan lang ng 2 yon. This is from the formula, class. Yung general formula ng derivative. Papalitan lang yun ito. Okay? And then given yung function. Yung kaninang sinasagot natin, ito lang din yun. Dito in the context of velocity, position and time. Okay? So 15. So at that instant, nung after 2 seconds, ito yung velocity ng ball. After 1 second, ito siya. Pero kapag average, ito siya from 1 to 2. Ito yung average. Okay? Ngayon, paano makuha yung general? We can get the general, kumbaga, formula to get the instantaneous velocity, di ba? So, i-retain mo lang si t sub 0 kasi wala kang given dito. Okay? So, naging ganito siya. Factoring, ayan, nag-factoring dito. then t minus t sub 0. T sub 0. Ayan. So, naging ganito siya. Okay? Again, assignment, kung paano nakuha ito. So, ito yung sagot. Ito yung general formula natin to get the instantaneous velocity. Okay, take note class, kapag after 4 seconds, yung instantaneous velocity is, kung 4 yan, so 10 times 4, 40, di ba? 35 minus 40, negative 5. Negative yung velocity. Pwede ba yan? Pwede yung negative velocity class kasi vector quantity naman yung quantity. Yung velocity. It means yung negative simply means yung direction. Dito, kapag pataas, positive velocity yan. Pero kapag dito, bumaba na siya, downward, negative velocity. Kaya after 4 seconds, negative yung velocity niya.